Hello, before we start, I'd like to introduce myself. I'm Nick Sutherland, and I'm the Esri lead for national security, which includes both defence and intelligence, as well as public safety in Europe. I'd like to introduce my two colleagues, Tony Giles, who works with me on the European team, and Tim Murphy, who is based in the US. We work very closely with our colleagues in Esri Ukraine, and together, as One Esri, we're committed to providing you the best experience in your use of a GIS, a Geographic Information System, to meet your ongoing operational requirements, and therefore we welcome the opportunity to present to you today. We all have extensive experience in the implementation of use of Geographic Information Systems in a national security setting to deliver the geospatial information necessary to ensure shared situational awareness across your national security enterprise, and secondly, the geospatial intelligence required to support rapid and accurate decision making. Both are core components of meeting cyber requirements. In the brief today, I'll provide a short overview of what a GIS is and its relevance to national security, and then we'll provide demonstrations of two solutions that we have that highlight you can undertake analysis and exploitation of complex data sets. 90% of all government and military agencies in Europe use Esri's ArcGIS as their primary GIS. The map on the left reflects the countries in green that have formal agreements with Esri, known as enterprise agreements, and those in orange highlight those countries that are major users. Note, we hope that Poland, Lithuania, and yourselves in Ukraine will move towards an enterprise agreement in the next 12 months. At an international level, NATO is a major user of ArcGIS through the NATO CoreGIS GIS project, and it is deployed extensively across the NATO command structure as well as in NATO headquarters. In the European Union, it is deployed in the EU military staff on overseas missions, and finally, it is used across the Five Eyes intelligence community. So we can see that a common technology is deployed on national security missions at a national, a regional, and an international level. The organisations that we work with are facing uncertainty to a diverse and often interrelated set of challenges. These include natural disasters and hazards, as we've seen recently with flooding in Europe, and more recently the extreme weather patterns in the US, with IT systems failing, all of which lead to and cause significant disruption. The vulnerability of the IT infrastructure leaves them open to deliberate cyber attacks, whether by small groups or at the state-sponsored attack level, and the targets are often part of the critical infrastructure have major impact. We saw more deliberate sabotage, which was targeted at the French high-speed rail network in the run-up to the Paris Olympics. And finally, we see the impact and consequences from modern warfare. I now provide a short overview of what a GIS, a Geographic Information System, is. It provides the ability to understand the environment around you. It provides context through the ability to sense, collect, map and visualize features in space and time. And it allows you to gain understanding by modeling and analyze this data, and then to make informed decisions that are accurate and timely. Finally, it allows you to take action, whether as an individual or collectively by sharing with others. This is very similar to the intelligence cycle used in defence. Based on your role and your mission, you determine what data needs to be collected and processed. This then can be analysed and the resulting outputs used to inform the decision-making process, with these decisions communicated across the command structure. At its simplest level, a GIS has four components. The first on the left is the system of record, where you have the ability to discover, access and share data that is relevant to you. The second at the bottom is the system of insight, and this provides a powerful set of tools that can be used to analyse and exploit the data. On the right, we have the system of engagement, into which both the outputs of the system of record and the system of insight are taken, and then shared via the system of engagement. This provides the ability to share data between users, systems and communities of use, whether to the individual deployed on the ground or to commanders in their ops centre. Underpinning all of this in the middle is the geospatial infrastructure, which hosts the data, the systems and the services. We'll now look at each system in more detail. As I mentioned before, the system of record is the ability to integrate all types of data and this provides the foundation datasets which can be used to provide situational awareness. Datasets include the more traditional topographic and charting products, different forms of video feeds, imagery feeds, but also to the vast amounts of data that can be captured in real time through the Internet of Things. They're challenging to bring them together, ensure that they can be discovered, retrieved and visualized by users. We also have the tools to undertake a whole variety of complex analytical tasks. For example, measuring features on the ground, the width and potentially the depth of a river, understanding what is going on in a particular time at a particular location, detecting and building up patterns of life, then trying to predict the courses of action based on past behaviour. The tools available range from simple apps that are available on mobile devices or through the web to higher-end technology such as ArcGIS Pro, which is the entry-level software package for analysts. The system of engagement is the ability to provide the information to a wider range of users so that they can have shared situational awareness and also access the information required to make decisions. This includes the ability to collect data directly in the field through the use of tools such as Survey 123, to provide simple map viewers to visualize foundation datasets relevant to you, or dashboards where multiple data feeds can be monitored and analyzed in one view, and then simple briefing products such as story maps to help brief a wider audience. As we said before, underpinning this is a geospatial infrastructure. It can be deployed on-premise, in the cloud, or in a hybrid combination. The challenge is to make sure the infrastructure supports interoperability between users and systems, and does that in a secure manner so you can collaborate within your organization, with other organizations, whether on a national or international level. And again, the challenge is being open and interoperable. I'll now focus on two demonstrations that highlight the power of what you can achieve through the system of insights. Underpinning insights are the powerful set of engines that we maintain that can be used to visualize, analyze, and exploit complex data sets. On the left, we have tools that include AI and machine learning. We have the tools that can analyze data in real time or in vast quantities and perform network and routing analysis. We'll focus on two of these capabilities and provide short demonstrations of how they might be used to support many demanding missions that you're responsible for. The first we'll look at is ArcGIS Knowledge. ArcGIS Knowledge allows you to exploit graph data and knowledge stores. In its simplest form, a graph database is a special kind of data store that's been optimized to store the connections between things, what we call entities, facts about these entities, properties, and how the entities relate to each other, we call relationships. Entities can be comprised of people, places, events, and other sorts of objects, such as structured observations. Leveraging this type of model allows users to see their data in context, and by discovering related entities can reveal patterns and relationships that may have previously been unknown. Analysis can be visualized as link charts, histograms, or displayed on a map. You'll gain geospatial context. There are massive volumes of data available, but are unable to exploit much of it, and as a result, the decisions are often based on an understanding that is not as deep and comprehensive as it could be. My colleague Tim Murphy will now demonstrate ArcGIS Knowledge.
This is a demonstration of Esri's new enterprise data fusion product called Knowledge. In this workflow, we're going to start by walking through different tables of cyber data, such as the Common Vulnerability and Exploits dataset, as well as the MITRE ATAC dataset, as well as finally the APT groups and operations. This is a dataset provided by CyberOps that walks through the different countries and the hacking groups that they support. All of these different silos of information have been fused together inside of a knowledge graph. To begin with, this allows us to look at the physical real world, but to be able to enrich it and understand the different exploits and attacks occurring in cyberspace between these different countries. We can start with an opening question. Looking at Ukraine, wanting to be able to better understand the different countries behind the cyber attacks going on in Ukraine. as we select Ukraine, we can start expanding it or understanding how it's related to everything else in the graph. This begins with looking at who's attacking Ukraine, and of the different hacking groups that are attacking Ukraine, understanding where these hacking groups originate from, bringing us to Brazil, China, and finally, Russia. This information can also be presented in a variety of other formats, including being able to use the Pro tool to be able to build the report that you see here, a WYSIWYG report generating capability called Layouts, which is built into the product. For us to accomplish what we just did, we brought all of the different tables of information into this knowledge graph, breaking everything into a series of entities, such as the vulnerabilities or even hacking campaigns, and also relationships, how the different entities are related to one another. In this case, looking at the 2016 Ukraine electric power attack and being able to understand the different ways that the attack was carried out, including information on the hacking team that went after it. All of the information inside of a graph is connected, allowing us to easily traverse through everything in the graph. Inside of knowledge, everything is also searchable for being able to quickly and easily look up any, in this case, hacking group and understand what you already know about it, as well as what information you might not know. This allows us to ask other complicated questions, such as given Iran, what are the different hacking groups that Iran supports, and what are the different exploits that those different hacking groups are known to work with? We can also explore this information further, such as looking at the different hacking groups and selecting just the hacking groups, asking the graph to help us understand the connections between the different hacking groups, to understand are these three different independently and operated organizations, or are they all sharing information, which they appear to be, for different techniques and approaches for being able to attack different systems. Key to being able to have one place to be able to have all of your intelligence information connected. You can also add information that you know about. I may want to assert that these two organizations are working with one another, and I can create an associated with relationship between the two hacking groups. Now, what I know about these two organizations is immediately actionable and accessible by all the other analysts working inside of this knowledge graph. Finally, all of this information is also consumable inside of our new web-based interface. This allows you to be able to search for all of the same entities that we were just looking at, but inside of a browser interface, such as being able to search for solar winds and be able to go directly to the data card for solar winds, or be able to add this record to a new link chart to understand the network around it. Spatial or non-spatial data, structured or even unstructured data, can all be connected together, complete with the information the analyst knows, intrinsic knowledge, and it can be fused together inside of our new ArcGIS knowledge product.
We've run many workshops with individuals understanding or wanting to understand ArcGIS knowledge over the last 18 months. Many of these are intelligence analysts, and they now recognize better the value that being able to geospatially represent, visualize, and analyze complex data sets brings to them and to their tasks. The second area we'll look at is big data analytics. The scale and complexity of data has grown significantly in recent years, and GeoAnalytics Server and GeoAnalytics Engine allows you to process these data sets at a massive scale. To some users, 50,000 records collected over a 10-year period represents a large data set, but we'll see in the demo that this is dwarfed by billions of records that are collected each month, each week, or even each day. Apache Spark supports spatial analysts, both when conducted on distributed or parallel computers. They provide the ability to ingest and analyze vector and tabular data and identify activities and incidents that have a spatial and temporal component. ArcGIS Geoanalytics Engine is a powerful engine that makes working with spatial data and performing spatial analysis easy and intuitive for the data scientist. It's cloud native and Spark native, which means you can access your data where it lives and run it directly in Spark. It requires ready-to-use analytics that support your data science workflows, so there's no need to index or transform your data. Instead, you can get started right away and use Python and SQL to build models for working with geospatial data. And it gives the results where you need them. You can write the results back to your data lake, your data warehouse, your GIS, or your business intelligence application. Geoanalytics Engine is available where you need it. We support all major cloud providers, which include Microsoft Azure, AWS, and Google Cloud. We also support the Databricks Spark environments available for each of these cloud platforms. And this means that you can easily stand up Geoanalytics Engine on your preferred cloud and get it to work quickly. In this demo, Tony will analyze AIS data, automatic identification system data collected from ships to identify patterns and trends that are not readily discernible. While we use ship's tracks in this example, it could equally be feeds from mobile phones or from aircrafts.
In this demonstration, I want to talk a little bit about the Geoanalytics Engine, which is really the premier solution in our system for processing true big data. I'll skip over these first two slides as we've just seen them in the presentation, but let's talk about the key features again. Actually, before I even dive into those, let me explain. We're actually in a Microsoft Azure Databricks environment right now. This is a very common big data and data science workspace to use. It operates in a similar way to Jupyter Notebook, but is totally independent. Just to reiterate, the Geoanalytics Engine can be run entirely independent of your ArcGIS system. It has no dependencies to any part of the ArcGIS system to use it. You just need the engine itself. So key features of the Geoanalytics Engine are that it's fully integrated with Apache Spark. With that, it's easy to use and you don't need a full ArcGIS Enterprise environment to run it. It extends PySpark with over 120 plus spatial type functions. We can read and write to many of the common data formats, and of course, it's cloud native. So let's walk through this notebook step by step and I'll explain what's happening at each stage. I apologise for showing code, but I'll endeavour to try and make it clear to what's happening. The first thing we need to do is import the libraries and functions that we want to utilise in the notebook. Here we can see a few of the spatial tools from the GA engine that we're going to use, such as aggregate points, find dwell locations, and reconstruct tracks. The data we're going to use within this demonstration is 1 month's worth of ship AIS data that I've downloaded from the Danish Marine Authority and converted from CSV to Parquet files. Parquet is a big data optimized format rather than working with CSV. It gives a faster input and output rate, allowing us to really work with those large datasets. We use the Spark native reader to reach out to the folder Parquet files and use one of the ST functions from the GA engine. We create a point geometry for longitude and latitude columns, passing in the spatial reference. We also do a date time conversion to make sure we have a true date field instead of a text column, and pass that to a new column called timestamp. So that whole process took less than a second to execute, and this is the results of what comes out. For each location reported, we see how the number of attributes, such as the type of the transmitter, the MSI number, navigational status, but more importantly, the last two columns we've created on import, the geometry and the time fields. So nothing too groundbreaking here. We've just created a data frame from our input data. What I think is quite exciting is in less than a second, we actually processed over 302 million records. If you're trying to load that type of data with CSV using some of the traditional methods, you might have to hit run and go out to lunch and come back. But now we're reducing hours of processing to seconds. So how can you get your quick and actionable insights from all this data? Again, think how long this would take you. The way you're probably doing things today, to process millions if not billions of records will probably take several hours. Using the Geo engine, we can use those built-in functions, something as simple as the aggregate points, where we can specify a bin size, in this case 1 kilometre or 1,000 metres, and type in the type of bin we want to create. For this, we'll use hexagons. In less than a second, we end up with a new data frame with a polygon geometry of each hexagon, and a count of how many original points intersect with each of that polygon. I've loaded that result up in a map, and we can see in a matter of seconds we've reduced the data down and we're starting to highlight patterns in the data, such as the main shipping routes or areas of fishing activity. We can click on a hexagon and see how many underlying points were contained within. That's just one simple example of an analytic that can already provide some insight to the data. Now we know a little bit more about the dataset, how can we characterise activities of interest? In this case, I wanted to look at a specific port of interest and try to understand what ships are docking within the port for a specific amount of time. From the full dataset, we can create a selection based on a bounding box around the port of Flensburg, returning just the ship's location, call sign and timestamp. The key things we would need to do any track analytics are a unique identifier, a spatial location and a timestamp. We'll use the find dwell locations function to return what ships have stayed within 10 metres of the same location for a minimum of 12 hours. Again, less than a second to run that analytic. The result shows we have 22 ships that meet the criteria, and we can see the start and end time for each ship dwell. Let's visualise that output on a map. The next step is to look at where else those ships have travelled over time. So from the full dataset, we can filter out the ships of interest by their call sign and then use the reconstruct tracks function to create a route from the individual points. This time we can see the output geometry as paths or lines. For the last time I put these results on a map, and we can see a couple of ships just remained stationary within the port while others took fairly long voyages. To summarise that up, we're taking the processing of millions of records and then applying our aggregate and spatial analytics to it using the power of the Geo engine, and then pushing this out so we can immediately make our decisions against it, reducing what could have been days, weeks, hours of processing down to a matter of minutes. And all this can be automated to run on the schedule, allowing decision makers to consume the visualizations without having to write any code.
The ability to manage and analyse vast datasets will help you to better understand what is going on around you. Identifying patterns and trends will allow you to respond more rapidly and in a more focused manner. Underpinning the deployment of a GIS is a need for a geospatial infrastructure, and the infrastructure needs to be deployed and tailored to meet your individual and organisational requirements. Users can access it perhaps through Pro, deployed on desktop, through apps, through devices and through the web, and coming through a portal to ensure that you can access the data and the analytics required for you to undertake your tasks. We recognise that the geospatial infrastructure must support modern, secure clouds, so we're developing the security and the cloud-ready approach that will allow you to deploy effectively. We recognise the need to be compliant with standards, with FedRAMP or with ISO, and we recognise the need to deploy solutions across security domains and being able to operate perhaps between unclassified and restricted and secret and top secret. And we also recognise the need to protect data, so each user only sees the data that is relevant to them. In conclusion, we've highlighted the range of functionality that a geographic information system can bring to you and the organisation that you're supporting, and highlight that we recognise some of the challenges you face when deploying technology. In a way, the technology is the easy bit. You need to ensure that the capabilities deployed reach across your organisation, that the system and the data are interoperable, both across your organisation, but also with other mission partners nationally and internationally. And finally, that your staff are trained to operate the systems deployed effectively. Many thanks for your attention. Please feel free to reach out to us, whether directly to Esri Ukraine or to Esri in Europe or in the US. Thank you.